Hello friends, Mr. Burrell here. We're in the middle of talking about solving quadratic functions. We've solved by square root. We've solved by factoring using the zero product property. Now to prepare us to solve other types of quadratic functions, today we're going to talk about what we call the discriminant. We're going to talk about what the discriminant is, kind of a funky word, but we're going to talk about what the discriminant is. It's going to help us to determine the number and types of solutions of a quadratic function. So that's what we're doing today. We're talking about how can we look at a quadratic function and determine how many solutions it has and what kinds of solutions it has. So by the end of this lesson, this is what I hope you're able to do. I hope you're able to find the discriminant of a quadratic function. We're going to talk about that. I hope you're able to use the discriminant of a quadratic function to find how many solutions that quadratic function has, and also be able to use the discriminant of a quadratic function to know the types of solutions it has. If none of that's ringing a bell, that's okay. We'll review it in this lesson. So just as a reminder, remember, here are the different possible solutions of a quadratic function. So a quadratic can have either two real solutions, like 4 and 5, two complex solutions, like 4i and 5i. We'll talk about how that happens in a little bit. But it can have two real solutions, two complex solutions, or imaginary solutions, or one real solution repeated twice. We had this example, we did an example like this in the last lesson, in the last video, where we had one real solution repeated twice. Those are the three different possible outcomes you can get, the three possible different types of solutions that a quadratic function can have. So before we talk about what the discriminant is, recall what the standard form of a quadratic function looks like, because that's going to come in handy. ax squared plus bx plus c equals 0. So with everything on the left side of the equal sign and then just a 0 on the right side of the equal sign, or vice versa. So the discriminant, this fun word, the discriminant allows us to identify how many solutions we have, as well as if they are real or complex solutions. Again, complex solutions means they contain imaginary numbers. The formula is based on the standard form of a quadratic equation. So basically, I can take a look at the standard form of a quadratic equation like this. Without even solving it, I can figure out what kinds of solutions is this going to have. Are they going to have real solutions? Is it going to have complex solutions? Is it just going to have one solution repeated twice? Without even solving, I can determine what kinds of solutions and how many I'm going to have. So here's the standard form of your quadratic function again. This is the formula to find the discriminant. B squared minus 4 times a times c. So notice from that formula, b is going to be this number right here, the number that's in front of x. A is going to be this number right here, the number in front of x squared. C is going to be the number right here, the number by itself. So b squared minus 4ac, that's the formula to find the discriminant. So when you calculate all that, when you take b squared minus 4 times a times c, if the answer you get is positive, if the discriminant is positive, you're going to have two real solutions. Real meaning they're not imaginary, so they can be positive, negative, fractions, or decimals. They're going to be two real solutions. If I have a discriminant that's negative, so if I get all this and I get a negative number, that's a sign that I'm going to have two complex solutions, or that means my solutions are going to contain I. They're going to be imaginary numbers. If I have a 0 discriminant, that means that I'm going to have one real solution repeated twice. So a positive discriminant gives me two real solutions, a negative discriminant gives me two complex solutions, a 0 discriminant gives me one real solution repeated twice. And I find the discriminant using this formula. You can write that down, it's in your notes, you can keep it, you can use that on the test. I'm not going to require you to memorize it, but that's what the discriminant formula is. Okay. So now we're going to go through some problems and we're going to find the discriminant and to determine how many solutions this quadratic function is going to have. So the instructions here say find the discriminant of the following functions, state the number and type of solutions of the function. So again, making sure that the function is in standard form and replacing missing terms with the number 0. We'll get to an example like that in a minute. So first, is this quadratic in standard form? Ax squared plus bx plus c equals 0. Yes, it is. Okay, to find the discriminant is b squared minus 4 times a times c. So I need to identify what a, b, and c are. A is 3, b is negative 6, c is positive 1. Okay, let's plug all those numbers in. Let's do some math. So the discriminant is equal to b, which is negative 6 squared, minus 4 times, and I'm going to use parentheses to do my multiplication, 4 times a, which is 3, times c, which is 1. Okay, remembering my order of operations, I have to do my multiplication and division from left to right before I can do any subtraction or addition. So negative 6 squared, or negative 6 times negative 6, is 36. And I have this minus, and then I have 4 times 3 times 1. 4 times 3 is 12, times 1 is 12. So 36 minus 12 is 24. So my discriminant is 24. That's a positive number. What does that mean? That means I'm going to have 2 real solutions. I don't know what those solutions are yet. We're going to talk about how to find those. We've talked a little bit about how to find those, but we'll talk about more how to find those in the next lesson. But right now, all I need to determine is how many and what kind of solutions I have. So my discriminant's a positive 24, meaning I have 2 real solutions. Okay, let's do another one. Here I have x squared minus 4x equals negative 4. First, am I in standard form? Ax squared plus bx plus c equals 0. No, I have this negative 4 over here, so I need to add 4 on both sides before I start. So I have x squared minus 4x plus 4 equals 0. Now I'm good. So I need to find the discriminant, which is b squared minus 4ac. A is equal to the number in front of here, which is 1. B is equal to negative 4, and C is equal to positive 4. Okay, let's plug those numbers in. D equals b squared, so negative 4 squared, minus 4 times A, which is 1, times C, which is 4. Okay, let's simplify this a little bit. D equals negative 4 times negative 4 is 16, minus 4 times 1 is 4, times 4 is 16. So 16 minus 16 equals 0. When my determinant is 0, remind yourself what that means. When I have a determinant that is equal to 0, that means I'm going to have one real solution repeated twice. One real solution repeated twice. So kind of like that example I had in a couple videos ago when I had x equals 1 and x equals 1. It would be a situation like that. One real solution repeated twice. I don't need to go and factor this and find what that solution is. For right now, I just need to know and find that there's one real solution repeated twice because the determinant is equal to 0. Okay, let's do a couple more. So I have negative x squared minus 7 equals 3x. So I need to get this in the form ax squared plus bx plus c equals 0. Or I can put it in the form 0 equals ax squared plus bx plus c. It doesn't matter, they're equivalent. So notice here, my a always needs to be positive, and here my x squared term is negative. So I'm going to go ahead and actually add x squared to this side, and then also add 7 over to this side. So I'll have 0 equals, and I'm going to put these in standard form, x squared plus 3x plus 7. I want my x squared term to be positive. Okay, so my determinant is b squared minus 4 times a times c. So what's my a, b, and c values? Let's write them down. A is 1, b is 3, and c is 7. So let's plug all those in. The determinant equals b squared, which is 3 squared, minus 4 times 1 times 7, because a is 1, c is 7. Okay, let's simplify this. 3 squared is 9, minus 4 times 1 is 4, times 7 is 28. 9 minus 28 is negative 19. So my discriminant is negative 19. What happens when I have a determinant value that is negative? Well, that means I'm going to have two complex or imaginary solutions. So since my discriminant is negative, in order to determine the number and type of solutions, I know that that tells me that I have two complex or imaginary solutions. And again, right now I'm not concerned with finding what those solutions are. I'm going to do that in the next lesson, in the next video. But now I know, without even solving it, that I'm going to have two solutions that are complex. Okay, let's do this one. 3x squared plus 1 equals 0. So I need this to be of the form ax squared plus bx plus c equals 0. Well, here's my a term, here's my c term. There's not a bx term, so what's that going to be? I can rewrite this as 3x squared plus 0x plus 1 equals 0. So yes, my b value is going to be 0 because there's none of them there. That's fine, we can still work with that. So the discriminant is b squared minus 4ac. What's a, b, and c? A is 3, b is 0, and c is 1. Okay, let's type those values in. D is equal to b squared, which is 0 squared, minus 4 times a times c, or times 3 times 1. Well, that's equal to 0 minus 4 times 3 is 12, times 1 is 12. So 0 minus 12 is negative 12. My discriminant is negative 12. What happens? What do I know about a discriminant that's negative? That means my quadratic function is going to have two complex or imaginary solutions. And again, right now I'm not concerned with finding those solutions, just knowing what kind of solutions they are, and they are complex. They're going to be complex solutions. Okay, let's do one more. We're going to do this one right here. So we need this to be in standard form, and right now it's not. It's in factored form. X minus 1 squared, or in other words, x minus 1 times x minus 1. So I'm going to show you kind of a cool thing with this later, but I'm going to, in order to find the discriminant, put this into standard form. So since it's factored here, I'm going to go ahead and multiply these back together, either using my rainbow method or my box method here. I'm going to multiply those together, and I'm going to get x squared minus 1x minus 1x. Negative 1 times negative 1 is plus 1. When I combine these together, I get x squared minus 2x plus 1 equals 0. So now it's in standard form, a, b, c. Well, my determinant is b squared minus 4ac, so let's find my a, b, and c values. A is 1, b is negative 2, c is 1. So if I plug that into my discriminant formula, b is negative 2, so negative 2 squared minus 4 times a times c. Just like that. Negative 2 squared minus 4 times 1 times 1. So negative 2 squared is negative 2 times negative 2, which is positive 4, minus 4 times 1 times 1 is 4. 4 minus 4 is 0. So my discriminant is equal to 0. What does that tell me about the number and type of solutions I'm going to have? Well, that tells me that I'm going to have one real solution, but that real solution is going to be repeated twice. So I know from the discriminant formula that I have one real solution repeated twice. So now I want you to go back and look at this original equation. I had x minus 1 squared, or x minus 1 times x minus 1 equals 0. If I reflect back to my last lesson, right now I could find out what those solutions are. Because x minus 1 times x minus 1 equals 0, that means x minus 1 would have to be equal to 0, or this other x minus 1 would have to be equal to 0, When I add 1 on both sides in both of those, I get x equals 1 and x equals 1, repeated twice. So I didn't necessarily need to find the discriminant in this problem to know how many solutions there were, because this was already in a convenient form to solve. So I could solve for x, figured out that x was equal to 1 and 1, so I had one real solution repeated twice, but I could also use the discriminant to find that out, to find out that there was one real solution repeated twice. Sometimes it'll be easier to do this in a problem like this where it's not already factored. It would probably be easier to use the discriminant. So you can go over this example by yourself if you would like. But that's what I got for you today. So hopefully now you're able to find the discriminant of a quadratic function. Remember that formula is b squared minus 4ac. Don't need to memorize that necessarily. I will give it to you. You'll use it a lot. And I want you to be able to use the discriminant of a quadratic function to find how many solutions it has. Does it have 2 solutions? Does it have 1 solution repeated twice? And I hope now you're able to use the discriminant to know the types of solutions. Are they real solutions or are they complex solutions? So that's all for this video. We're going to be using the discriminant in the next lesson a lot. We're going to talk about using the discriminant now as part of a formula to find solutions to all types of quadratic functions. So I hope that was helpful. Please reach out if you have any questions whatsoever, and I hope you enjoyed that as much as I did.